Okay, so we're here today to talk about the intermediate value theorem. Okay, and so we're going to jump right into this and we're going to talk about the intermediate value theorem says if f is a continuous function from some number x equals a to some number x equals b, then every value between f of a and f of b exists at some point on the interval from a to b. Now that may sound a little funny because we're not used to reading definitions like this, but basically this is what it's saying. And I'm going to go through the definition as we talk about this first example. It says, given the graph of g of x equals 2x minus 1, is there a value of c in the interval from 2 to 5 such that f of c equals 7.5? So let's draw a picture of what this looks like. So I'm going to start off and I'm going to draw the graph of 2x minus 1, and I'm only going to graph it from 2 up to 5. So that's the interval that we're looking at here. So I would mark my axis with 2 and 5. And so I'm just going to do this the easy way. I'm going to plug in 2 to the equation. 2 times 2 is 4, minus 1 is 3. So I know what I would have a point somewhere up here, or exactly up here, at 2, 3. And if I plug in 5, 2 times 5 is 10, minus 1 is 9. So I have another point up here at 5, 9. And I can simply draw the line between there because that's exactly what this function is. It's a straight linear function. And so this is continuous. This is a continuous function. That was the first part of our intermediate value theorem. You'll notice it says if f is continuous. So we have to know that f is continuous, okay? From x equals a to x equals b. Well, so here is my a. My a is going to be 2, and my b is going to be 5. So on the interval from 2 to 5, then every value between f of a and f of b, so f of a is the 3 value right here. This is f of a, the y value. F of b exists at some point in the interval. So basically, if I can show that there's a y value at 3 and there's a y value at 9, then every other y value has to be included in there. 3.1, 4.7, 5.9, whatever it is. Every single y value in there exists in that function. And the reason it exists is because f is continuous. And this could happen with another function, even if it's a curve like that, and I could show that, okay, this is 3 and this is 9 again, then every y value between 3 and 9 exists because my function is continuous. So how do we say this? This is where we need to start writing a little bit in calculus. So from my graph, I can see that, yes, that's true. Yes. Is there a value of c in 2.5, in the interval 2 to 5, such that f of c equals 7.5? Okay, so I'm going to just take a wild guess here, and I'm going to say right about here is 7.5, right? So the answer is yes. But I can't just say yes and move on. I'm going to say this. Since g is continuous, okay, so that's the very first thing that the intermediate value theorem says. Is your function continuous? So if I don't know that the function is continuous, or I can't automatically say that the function is continuous, then I'm in trouble here. All right, and by the way, I just noticed this should say g of c right here, not f of c. All right, that's just me messing up on my typing. Since g is continuous with, okay, so I have to say it's continuous, and then I have to physically show a value that is above 7.5 and a value that is below 7.5. So I have 2 values. When I graph this line, I found 2 values. I found the point 2, 3. So I'm going to say with g of 2 equal to 3, there's my value below 7.5. and g of 5 equal to 9, there's my value above 7.5, then there exists a value of c. So we can just say a c in the interval, so I'm going to use this little symbol for in the interval 2 to 5, such that g of c equals 7.5. And I have to say all of that, okay? So take a look at the next one. Example number 2. Here's your key right here. Let f be a continuous function. That means no gaps, no holes, no vertical asymptotes, none of that good stuff. All right? On the interval from -4 to 13, some selected values of f are given in the table. You notice my table starts at -4, goes all the way up to 13 with some selected values. Not every value, obviously. First question says, is there a solution to f of x equals 0? Well, if I start to look at my table goes from 11 to 2 to -6. Now, when I went from 11 to 2, did my graph necessarily hit 0 in that interval? No. Could it have hit 0? Yes, it could have. Did it have to hit 0? Absolutely not. I go to the next interval. From -2.3 to 0, my graph goes from a value of 2 to a value of -6. So again, let me give you a little picture of what we're looking at here. So I am going from this, okay? So I'm just going to call this -2.3, and it's telling me that my graph is up here somewhere at 2, okay? And then I'm going to 0 all the way down to -6. So I'll just put -6 down here, and we'll put a point right there. Does that graph have to touch the value of 0, a y value of 0, as it goes from the top to the bottom? Well, absolutely. I don't care if it's a straight line. I don't care if it's a curve. I don't really care what it's doing, but it has to hit 0 somewhere in that interval in order to get down to -6. So my answer here again, yes, it does. How do I know that it does that? Well, again, since f is continuous, you have to say that, continuous, with the next thing I want to show is a value above and a value below 0. Okay, when we talk about values above and below 0, we're looking at the y values here. So, since f is continuous with f of -2.3 equal to 2, there's my value above, and f of 0 equal to -6, that's my value below, then there exists a c in the interval from -2.3, 0, such that f of c equals 0. That's it. To show that a function has a particular value, you have to show two things. You have to explain two things. You have to be able to say that it's continuous, and you have to be able to show a value above and a value below in order to say that. I would encourage you to turn off the video or stop the video, see if you can do the next one on your own. It says, on what interval does f of x does f of x equal 9? Okay, well, I'm going to start back at the beginning here. Check it out. I go from the first value at -4 to -2.3. I'm going from 11 down to 2. Well, I must have hit 9 in there somewhere. I had to have. So this time they're not asking a yes or no. I would say on the interval let's see here, -4 to -2.3. And then it says to explain. Since f is continuous, how do I know it's continuous? Well, they told me that back at the beginning. With f of -4 equal to 11 and f of -2.3 equal to 2, then there exists a value of c in the interval from -4 to -2.3 such that f of c is equal to 9. All right, we're basically saying the same thing every single time. And then in example 3, they don't give us a t-chart, they don't give us anything, they just say, hey, look, given this function for all x greater than 0, so given f of x equals x squared plus 1, where x is greater than or equal to 0, is there an interval where f of x is equal to 2? All right, now if you know what this graph looks like, and again, this is important in calculus, I'm going to sketch a graph of this. It says it starts at 0. So if I plug in 0 to the function, I get 0 squared plus 1, which is 1. So the function starts right here at 0, 1. And it just says it keeps going and going and going. So if I graph the function at 1, I know that if I plug in 1, I would get out a value of 2. Well, there's my f of x equal to 2 right now. If I plug in 2, I get 2 squared, which is 4, 4 plus 1, which is 5. And so this is just a parabola that's going up like that. It continues to go up. But I have enough right there to say this. So I would say, is there an interval? Yes. Yes, there is. Yes. And I would even say, maybe I give the interval now, maybe I give it later, but I would say, since f is continuous, with, and again, all I have to do is show a value below and a value above. I know that f of 0 is equal to 1, and f of 2 is equal to 5. Then there exists a c in the interval from, let me see, 0 to 2, such that f of c equals 2. Okay, so the explanations are all pretty much the same here. Have fun with the homework there.